This is a trig equation involving the tangent function. So we have to solve tan x equals -2. The interval is given in terms of degrees, so you have to check that your calculator is also set in degree mode. The first thing we need to calculate in this kind of problem is the principal value. The principal value is the inverse tan function of -2. We're not going to get the exact answer here, so let's just work to one decimal place. So my calculator tells me that it's -63.4 degrees. The general solution for tangent is given as follows. Its x is 180n plus the principal value. As it's -63.4, it's going to look like that. Okay, so that's the general solution. As before, the next step is to try different values of n. So if we put n as 0 into this, we'll get a solution which is 0 minus 63.4. So that's giving us that value. That's within the interval, so it's acceptable. N equals 1. Well, that will give us x equals 180 minus 63.4, and to one decimal place that's 116.6 degrees. If we try n equals 2, well, that's going to give me 360 minus 63.4. That's too big. It's beyond the upper limit. So that's too big. Likewise, I think if we try negative numbers, if we try -1, that will give me minus 180 minus 63.4. That's smaller than the lower limit of the interval. So in that case, we don't need to work anything out either. It's too small. So we've got a complete set of solutions here. The only solutions to the original equation are minus 63.4 degrees and 116.6 degrees. In the exam you could check these were correct by substituting them back into the original equation to check that they were about -2. In this second example we've got another equation involving the tangent function. This time we have to solve tan x equals √3/3. The interval is given in terms of pi. That means we're using radians, so check your calculator is in radian mode. We begin by finding the principal value. When we're using radians, the principal value is tan to the -1 √3/3. That should be inverse tangent. And in radians, that has a value of pi/6 radians. The general solution is how we'll find the rest of the solutions. So it's a formula, and for the tangent function in radians it's pi n plus the principal value, so that's pi/6. As before, we try different values of n and make sure that the values of x are within the required interval. So with n equals 0, if we substitute this into here, we're simply going to get the principal value, which is pi/6. That's okay. If we try n equals 1, that's going to give us pi plus pi/6. And that's equal to 7 pi/6. If we try n equals 2, that's going to give us 2 pi plus pi/6, and that's equal to 13 pi/6. If we try n as 3, we keep going, well, that's going to give me 3 pi plus pi/6. That's bigger than the upper limit, so I don't need to do that. So if I was to try a -1, so -1 will give me minus pi plus pi/6, and that's smaller than the lower limit of this interval. So that means we found all of the solutions. So the complete list of solutions is pi/6, 7 pi over 6 and 13 pi over 6. In an exam, you could check that these were correct by substituting them back into the original trig function and checking that you get the value of root 3 over 3 or something close to it.